Hello everyone. In this video we are going to learn about the ellipse. We know that an ellipse is a conic section, and when we have learned this in the introduction part of the conic sections, then we said that a section cut from a cone by a plane not intersecting the base and not parallel to the base is an ellipse. Now if we talk about the analytical definition of the ellipse, then we can say that this is the locus of a point which moves such that its distance from a fixed point, that is focus, is less than the distance of the point from a fixed line, that is known as the directrix, is an ellipse. It means what? We can say that PS is less than PM. PS is less than PM. It means PS upon PM is less than 1. And we know that PS upon PM is the eccentricity. So the eccentricity of a conic section is less than 1, then it is an ellipse. Let's discuss now about the standard form of the ellipse. We say if an ellipse is along the x-axis and y-axis, then we say it is the standard form of the ellipse. Let's learn about some of the parts of the standard form. There are two axes of the ellipse. The greater one, the larger one, is known as the major axis, which is along the x-axis here, and that is A dash. The length of this major axis is taken as 2a. The smaller one is vertical, that is perpendicular to the major axis, and that is the smaller one, so it is known as the minor axis of the ellipse. Here it is B dash, and the length of B dash is taken as 2b. What is the center of it? Center, actually we know, for a conic section is the point which bisects every chord of it. So here origin is taken as the center which is bisecting every chord of it, and hence it bisects the major axis and minor axis also. So origin is the center here in this standard form. What about the foci? There are two focus of this, that's why we call foci, and these foci are S and S dash. These two foci are lying on the major axis, that is we can say x-axis, and the coordinates of that are AE, 0 and minus AE, 0. Then directrices. There are two directrices here, and they are both parallel to the y-axis, and the distance of each directrix from the center is A upon E. That's why the equations of the directrices can be given as x equal to A upon E, and this is x equal to minus A upon E. Then we have the latus rectum. We know that latus rectum is the chord which is passing through the focus and perpendicular to the main axis. So here it is perpendicular to the major axis, passing through the focus. So L dash will be the latus rectum. Same will be on this side also. Let's learn now how to find out the standard equation of an ellipse. To find the standard equation of an ellipse, we have to know first what are the vertices. A and A dash are known as the vertices of the ellipse, and we know here since A dash, that is the major axis, 2a. So the coordinates of A will be A, 0, and that of A dash will be minus A, 0. Now what is the relation between A and B? That is between the length of the major axis and minor axis. So here we are given that B square is equal to A square into 1 minus E square. It means we can say that 1 minus E square is equal to B square upon A square. Now we know for an ellipse, if we take any arbitrary point P here, the coordinates of which are x, y, then this PS will be the distance of the point from the focus and PM is the distance from the directrix. Then for the ellipse, we have that PS upon PM is equal to E. That is eccentricity. It means PS is equal to E into PM. PS, the distance between the focus and this point P. Distance formula can be applied. So that will be root of x minus AE whole square plus y minus 0 whole square equal to E into PM. We find the length of PM. PM here will be same as Qn if we draw the perpendicular from P to the x-axis. And this Qn can be written as ON minus OQ or not. ON is equal to A upon E, since the distance of this directrix from the center is A upon E, minus OQ is x, that is the x coordinate of P. So here we get it as E into A upon E minus x. If we multiply E, this will be A minus EX. If we square both the sides of it, perfect square, that is x square minus 2aEx plus A square into E square plus y square equal to A square minus 2aEx plus E square into x square. Here we find that minus 2aEx on this side and this side they cancel. If we transpose this E square x square onto the left, it becomes x square minus E square into x square plus y square and transpose A square into E square onto the right. This will be A square minus A square into E square. X square common. This will be x square into 1 minus E square. Plus y square equal to A square common A square into 1 minus E square. If we divide this by A square into 1 minus E square, we find it is x square into 1 minus E square upon A square into 1 minus E square plus y square upon A square into 1 minus E square. This 1 minus E square cancels this. So here we are getting x square upon A square plus y square upon B square equal to 1, since A square into 1 minus E square is equal to B square. So the standard equation of the ellipse is x square upon A square plus y square upon B square is equal to 1. And here we remember one thing, that A is greater than B, since the major axis is greater than the or larger than the minor axis. Now let's find out the length of latus rectum of the ellipse. Here this is the ellipse and L dash is the latus rectum. It is passing through the focus and the coordinates of focus are A, E, 0. If we consider that the length of this latus rectum is 2k, then S will be bisecting it, and hence we can say LS is equal to L dash S, that will be equal to K. So the coordinates of L will be AE, K, and that of L dash will be AE, minus K. Now we know that the equation of the ellipse is x square upon A square plus y square upon B square equal to 1 in this case. And L and L dash both lie on it. Now if we say that L lies on it, then L will be satisfying the equation. So we can substitute the values of x and y from the coordinates of L. And hence we get here AE square upon A square plus K square upon B square is equal to 1. That becomes A square into E square whole square of A upon A square plus K square upon B square is equal to 1. Here A square and A square cancel. Can we write here that K square upon B square equal to 1 minus E square if we transpose E square onto the right? So we get here K square upon B square is equal to 1 minus E square. Hence, K square is equal to B square into 1 minus E square. And we know that B square is equal to A square into 1 minus E square. So 1 minus E square is equal to B square upon A square. If we substitute that value here, will it be B square into B square upon A square? Or we can say B power 4 upon A square. It means K will be root of it, that is B square upon A. So the length of latus rectum will be 2K. and that is equal to 2 into b square upon a. So the length of latus rectum for an ellipse is given by 2b square upon a. We will continue the same in the next video, and in that we will be learning about the vertical ellipse, and also we'll learn about some of the examples, how to solve the problems based on standard equations. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.